Hello again, everyone. You're joining us for another episode of Executive Platform's Blueprint podcast series. My name is Jeff Mix. I'm head of content and research. My guest today is Willem Sundblad of Odin Technologies. We're going to be having a conversation about putting the power of AI in the hand of frontline workers. I think it's a very timely and topical conversation, and I always enjoy speaking with Willem. Willem, thank you so much for joining me today.
Thank you so much for having me. It's been a couple of years in a row now.
I guess. Well, we keep having you back because you can really communicate this stuff in an effective way, so thank you.
Thank you.
Why don't we start off by saying, I think you and I have both had a lot of conversations about AI in the last year and a half, and everybody sort of wants to know, what is it going to mean to me? And I think manufacturers especially are thinking, what is it going to mean for the people who are actually on the shop floor doing the work? What are your thoughts on that?
So I think I'll start from a different angle.
Okay, please.
I think the number one problem that almost all manufacturers are facing right now is the skilled labor challenge.
Okay.
It has been for many years one of these, or I'd say pre-COVID, it was a frog in boiling water thing where everyone knew that there was a retiring of the workforce. It was harder to add people. But after COVID, it has become the most acute problem. Turnover on factory floors is sky high. Tenure has just continued to go down. And if you look at just high level, what's the labor output per hour per worker in the US, it's been flat since 2010. And that's just because everyone's been trying to keep up with changes because, batch sizes have gone down, quality specs have gone up, complexity of processes have gone up, and seniority and tenure of staff has just, plummeted. So it's a really tough environment. Because also, these jobs are really hard. If you're an operator on a manufacturing shop floor, those jobs are really tough, and it takes a long time to learn them. I think for most of the industries that we work in, they always say that it's more of an art than a science. And I used to always think about, how come AI and data analytics bring more science to that process, but really it's about can we make it easier for them to become artists. And so there's certainly been a lot of hype around AI with ChatGPT and large language models. I think there are still kind of nascent adoptions of that in the industry. The things that we focus on a lot is how do we get junior operators to perform like experienced staff really quickly? And it comes in a couple of different forms. One that I think is really interesting is just predicting the quality of the product as it's being made instead of getting it 5 hours later from a lab. Because in these roles and in these processes, the cost of failure is very high. If you think of like paper manufacturing as an example, if you have a failure, you've just spent a lot of time making low-grade product, and it's going to cost the business tremendously. And you only get samples about every 5 hours if what you're doing is good or not. And so if you make a change and you're a junior operator, those 5 hours that you're waiting for the result, whether it was good or bad, are really stressful. So we build predictive models so that you get a prediction that's very accurate, or at least directionally right, second by second. That means that for the operator, you've just changed the whole way that they work. Because if they make a tweak to the process, they see right away that had the desired impact. And then 5 hours later, they get the extra boost that yes, and that was right. So it changes the feedback loop for the operators completely. And they start to really learn the process much faster. We found those types of tangible things to really remove a lot of the fear around AI, because we're just talking about practical solutions that actually change how they do things today. Like getting a quality result in seconds instead of 5 hours. Something that everyone knows, everyone can touch and feel and understand what that impact is going to be.
I'm so pleased you start off with such a concrete example, because my next question was going to be, there is hype around AI, but what is it actually delivering? Mm-hmm. This is an example of something that is really happening right now.
Yeah.
When we talk about the example of there is a skilled worker who maybe has been at that paper factory for 20 years and they're able from experience to know I'm doing everything right, that person may have retired, that person may have fallen ill. The junior operator coming in through this tool is able to match the same performance. How have you built the AI model to do that? Where is that data coming from? How is it helping the operator achieve their goal?
So there's actually multiple parts to this. The predictive quality is one piece, but the recommendations themselves of what process changes should you make is a separate model. And it's interesting because originally we started with just the predictive quality, and we thought that that would be a very strong use case in and of itself. We can prevent failures. But we noticed that the problem isn't as much that there are really big quality failures. It's that since the cost of quality is so high, people run things very conservatively in order to not mess up. So they're leaving opportunity on the table for both increased output or decreased material consumption, decreased energy. And so there's just waste in the fear of messing up. So predictive quality changes the feedback loop and the risk in making changes for these operators. But then we also look at the historical way that they have been running things, from the most experienced operators to the junior operators, and you usually end up with a pretty big scatter plot in variance. So for every product on every line, if you plot how they've been running things with like cost on one axis and throughput on the other axis, it's all over the place. And so what the recommendation model, the purpose is to try to get all of those into a much tighter grouping and get it always closer to the efficient frontier and push that efficient frontier. So a concrete example that one of our customers shared in the session earlier today was 3 different products on the same line. In 2023, I'll take one of these products as an example. They had an average production rate of 278 pounds per hour last year. The target for that product is 500. And some operators were able to run it at 500, but most of them weren't. And so with the process AI recommendations and predictions that we give, their average rate right now is 515. Because we've been able to pull everyone up to that higher standard. Because before, junior operators would come in and they would get the product to spec, to quality spec, and they would say, well, at least this is good enough. I'm not making bad product, and it's better to make something than to make nothing. I'm just going to stay here. When there was the opportunity to increase rates 40 or even 70% sometimes, if only they could know how to do it. Because some of these processes, they'll have 200 or even thousands of variables that goes into it. So these machine learning models can actually tell us which variables are important, and we can give recommendations on the variables that are controllable by operators and are important. So out of the 1,000 or 200 variables that exist, we might be giving a recommendation on 5 variables, like change your speed, change your melt pressure, change this chemical additive, do these 5 things, and you'll make the product at 500 pounds per hour instead, and your quality is going to be good. So that's been super rewarding to see, especially how operators have adopted it. Because for a long time in manufacturing software, there have been a lot of tools that have been built for executives and buyers, and there hasn't been a lot that's been built purposely for operators because they haven't had authority in decision making. Some people said, well, let's build it for the people who pay money. But I think the problem right now with the turnover, the skills gap has gotten so acute that people are just screaming for, give me something that helps the people who really make the product. And ultimately, if you're going to bring value, someone has to change something. Someone's going to do something differently than what they were doing before, and that's specifically the operators. They have to tweak dials, they have to run their machines in a different way, and both the kind of predictions, the recommendations, and the kind of constraint optimization of choosing which recommendation to give really helps level the playing field, or like bring everyone up to that experience level.
So I'm fascinated when you say, of 2,000 variables, we're going to focus on the 5 that are difference makers, because as you say, a lot of, data analytics software is for the executive who's trying to, track, a quarter's worth of progress, and there's, a million data points, and that's not what a plant floor operator needs. They need to know, what settings am I putting into the machine right now? So how did
winning or losing?
Are you winning or losing? How are you building software with the user in mind, where they are on a floor, they're doing a job, but they need to be able to understand the suggestions quickly without it being their whole job? They're not doing data analytics. They're looking at a recommendation and saying, yes, I've done it, or no, because this other thing has happened. What does that user interface look like?
So we've tried to make it as absolutely simple as we possibly can. So we can put on one screen the predictions for the key quality metrics that the operators needs to know about in order to make a good product, and the controllable variables that are important, and also the impact of the changes. So we can actually show, in some cases, even down to the dollar, and saying if you change these 7 parameters from X to Y, you will save this much money for this product. And we've also built that into leaderboards, actually. So like individual operators can see how much money they've saved, or shifts or crews. And that's been really cool to see how that gamification has also increased engagement and adoption. So this has been an iterative process with customers to build this product over many years. And even now when we launch new customers, the concept is always the same, the product is the same, but there is a lot of configuration and back and forth in the beginning. And it's interesting because it's something new for almost all customers, that you're doing AI-generated settings used by the operators. You're getting predictions in real time. They generally haven't done that before. And so you first have to win trust in, are the predictions accurate? If I use this recommendation, is it going to still make a good product? And so we kind of go through a first set of, I'd say, quantitative validation, where we actually expose the whole algorithm to them, and they can see, here are the variables from your process that goes into making this prediction. Here's how important this metric is. Here's how important this metric is. And there's usually a lot of interesting discussion with the domain experts about that.
I'm fascinated at how users embrace this new tool. I think it is a really interesting, you used gamification as one of your earlier examples. This is going to change the way that they work, but they want it. And I wonder, because so many of our conversations are about change management and persuading people that it's good, what is the tipping point with a tool like this on the shop floor?
So first and foremost, they have to trust it, and they have to find it genuinely useful so that they don't want to run the line without it anymore. And it goes through an interesting process where at first, you kind of have to gain the trust by being transparent with how these predictions made. We can actually give access to the full algorithm so they can see exactly how important certain variables are to the predictions, and can get that kind of quantitative understanding of why we make recommendations, why we make predictions the way we do. But it doesn't stick until they actually test it. And so that's when they get the intuitive trust outside of just the quantitative trust. And that means that they're going to go out there on the line and they're going to make changes to the process. They're going to see the predictions go in one direction and then wait to see the results, and that result reaffirms that the prediction was correct. Or they actually start using the recommendations, and again, they get the desired result. But in this phase of maybe like a month of it's configured, it is on the line for the operators, there's usually a lot of back and forth, or like, oh, hey, this recommendation isn't really working. We need to tweak this constraint, because all of it is configurable. You can say, I want recommendations that only optimize for speed. I want recommendations that optimize for material consumption. Or I want it to always get me closer to target. Or I want it to get me closer to target, but never below a certain, lower threshold. And so a lot of these back and forth tweaks happen in the first month. And eventually you get to a tipping point where they just don't look back. Like, they stop looking at it as we're validating this, we're running experiments, to just, this is how we run the line now. And I know it's one of the examples that Chris from Inks brought up in their team, that after they went through their validation experience, the operators said and the supervisors said, like, this is how we do things now. If we don't, we give up 35% improvement. And it's both a kind of operator comfort that it's just helping me do my job. I know that I'm not going to do anything bad, and I get the recommendation to do the right thing. It's a little bit of CYA also, because they could blame someone else if it's a mistake, so that's nice. But most importantly, the results just get sustained by that sustained usage, and they don't want to give up a 35% increase in rates.
No, for sure. I think a lot of manufacturers who are listening to this and imagining it on their own shop floor, you mentioned a month as a sort of example of tweak time. What is a typical timeline? And I appreciate everyone's story is different, but if somebody wanted to pilot this or try it in one plant, what is sort of the typical, from having a conversation with Odin, hey, we want to try this, to they're actually seeing results? What is usual?
So there's the I'd say there's the deployment time, which is just installation, and that's highly dependent on what's your bandwidth and capabilities of your IT and OT staff and current infrastructure. So I would say that is probably on the low end a month, high end 3 months, unless you're really in just pen and paper and you've got a lot of infrastructure to do, then it'll be longer. But for most manufacturers where this is the right step for them, it's 1 to 3 months based on infrastructure, bandwidth, and knowledge. Then you enter into the kind of validation iteration phase where the algorithms will be there pretty quickly. We've managed to productize that in a way that we can launch it very quickly, but there's always a little bit of iteration. Even if we're working with a customer in the same industry that we've worked with in the past, we're still going to iterate, tweak the models, make sure that they're really accurate, tweak the constraints, because everyone is a little bit different. And similarly there, I'd say that is 1 to 3 months. So 1 month probably on the low end, 3 months at the most extreme end. And that's really if there's maybe something wrong in the infrastructure, we need to redo some of the integration or do surge testing on quality because the quality tests weren't good enough to drive the accuracy we wanted in the model. But so that in total gives you a range of 2 to 6 months. And I think that is probably a range I'm comfortable giving that spans both maturity levels.
In the very beginning of this conversation, I was maybe using AI as sort of a high-level buzzword. And I think it is driving conversations and driving enthusiasm. But as you say, versions of this have been in manufacturing for a while, and it's only getting better. I wonder if we can talk about the generative AI piece, which I also feel is very buzzy and also probably very applicable to what shop floor people are doing.
Yeah. And it's a space that is moving very quickly, and obviously it has a lot of attention from everything from ChatGPT to people making videos and art and all kinds of things. It's moving at an exceptionally rapid pace. The application to manufacturing there that I'm the most excited about is how we can go even further on the domain knowledge piece. Because some of the predictions and recommendations that we've talked about so far, that is still AI, but it's more the machine learning that's been around for a while. And it really helps operators, but there's still a level of domain knowledge that's required from them. If you, as an example, are going to receive a recommendation of change these 7 variables from X to Y, they still need to know how they're going to do that. They need to know in what system they're going to make those changes, and maybe there's a sequence to how they're going to make those changes. And there is a big opportunity to capture domain knowledge from the whole industry and also from specific work instructions so that you can generate rich how-to information for the operators so that you can even further decrease the skill level required to really perform excellently on the line. And we're working on some of those things that we expect to go public with later this year. It's very exciting, and I think that is going to open up a new frontier on who we can hire into manufacturing and how quickly we can ramp them up to really perform. And specifically what I mean is just because you need both the domain knowledge of how that process works so that an operator could ask questions from the system of why are you recommending a change in this parameter when I see that the quality is drifting. They could learn directly from the system of what the relationship between the variables are. Or if the system's...
Let's pick it up from where you can say they can see the differences in the variables in the systems.
Mhm.
That was the last thing he said.
Okay.
Yeah.
And I can, do you want him to pick it up and we'll cut the camera, or do you want me to ask a follow-up?
As a follow-up, it works better that way.
Sure.
Yeah.
Oh, yeah, he's got quite a cough all of a sudden.
Yeah.
Okay. Clean audio for the podcast? So, as an example, what would they be asking? What are they seeing that they have questions about?
So they might ask, if Odin or our Process AI product is making a specific recommendation, they can just ask why. Why are we recommending this? And so they can actually learn from that domain knowledge. Or it could be that the system is seeing that something is happening on the line. We're going into a changeover. What am I going to do next? And we could actually then generate, a query and capture both the domain knowledge from the process and specific work instructions, then show them, here is the next step that you're going to do, and here's how you're going to do it. And that could be tied into the learning management system and everything else. So I think there's a lot of opportunity here, and the world's going to see very interesting solutions over the next couple of years.
It sounds very exciting, and I look forward to having future conversations with you about it. Before I let you go, though, I know we've covered a lot of ground already in this conversation. If there were one or two key takeaways you want people to think about a little further, what would you want to highlight for them?
Since the operator challenge or the labor challenge is the most acute challenge, we have to look at this from a need basis of what tools do they need in order to make it easier for them to perform, and how can we cut as many non-value added tasks out of those roles as possible through data analytics and automation, so that we make the roles better and easier, and that they can have a better day at the plant where they feel good about themselves, they're not too stressed, and they're just executing like champions. That's what we want to do. And it's a journey, but the tooling has gotten so much better quickly that you just got to start.
I think that's a great place to leave it on. Of course, I expect some people who have been listening to this may have their own questions, want to learn more. What is the best way to get in touch?
So www.odin.io is where you'll find all information about Process AI and about Odin, and you'll find many ways of getting in touch with us there.
And we will have that on the screen, but of course, for those of you listening to the podcast version of this, that's Odin with an E, the correct Scandinavian spelling of Odin.
Exactly.
Willem, it's always so great talking to you about this. Thank you so much for your time today.
Thank you so much.
Okay, you've been listening to another episode of Executive Platform's Blueprint podcast series. I've been Jeff Mix. Let's do it again soon.